Beneath distant, frozen shells, entire oceans of liquid water churn with unimaginable force. These concealed seas erupt silently through colossal cracks, shaping alien landscapes with icy fire. Imagine mountains of frozen water, taller than Everest, slowly shifting under immense tidal stresses. These incredible formations whisper tales of geological activity far more complex than we ever imagined. For centuries, humanity gazed at the outer solar system, seeing only cold, desolate spheres. Scientists once believed these distant worlds were geologically inert. Breakthroughs in planetary science unveiled a startling truth: hidden beneath their surfaces, mere cosmic ice balls. However, breakthroughs in planetary science unveiled a startling truth: hidden beneath their surfaces. Moons like Europa, Enceladus, and Triton are not dead, but dynamic canvases of slow alien geology. Their landscapes are sculpted by processes fundamentally different from Earth's familiar tectonics. These are worlds where rock-solid ice behaves like Earth's crust, constantly fracturing and reforming. The temperatures are so extreme that water ice becomes a geological material, not just a surface feature. Deep within, powerful gravitational tugs from their giant planet hosts generate immense internal heat. This ceaseless kneading prevents the subsurface oceans from completely freezing solid. Consequently, these worlds harbor conditions ripe for extraordinary geological phenomena. Understanding their unique geology could unlock secrets about planetary evolution across the cosmos. It challenges our very definition of what constitutes a geologically active world. The primary driver behind these alien landscapes is a process called cryovolcanism. Imagine a volcano, not erupting molten rock, but plumes of water, ammonia, or methane ice. These icy eruptions can reach hundreds of kilometers into space, forming giant geysers. On Enceladus, enormous jets blast from fissures known as tiger stripes near its south pole. These tiger stripes are deep, parallel cracks in the ice shell, constantly venting material. The material originates from a vast subsurface ocean, warmed by tidal forces from Saturn. This ocean is kept liquid by the gravitational dance, stretching and squeezing the moon's interior. When pressure builds, the liquid is forced upwards through the weakest points in the ice crust. As it reaches the vacuum of space, the liquid flashes into vapor and freezes instantly, forming ice crystals. But that's not the strangest part. These eruptions are not always explosive like Earth's volcanoes. Some cryovolcanic flows are slow, viscous glaciers of exotic ice, spreading across the surface. On Triton, Neptune's largest moon, dark geysers of nitrogen ice erupt, leaving streaks on its frozen plains. These plumes indicate an active interior, possibly warmed by residual heat from Triton's capture by Neptune. The nitrogen ice behaves like liquid lava, flowing and pooling in low-lying areas, then solidifying. Wait until you hear what comes next. These icy materials also drive a form of ice tectonics. Unlike Earth's rigid plates, these moons exhibit movements of vast ice rafts, pushing and pulling. Europa's surface displays chaotic terrain, where immense blocks of ice have broken apart and rotated. These icy jumbles suggest a thinner, more dynamic crust above a global liquid ocean. Scientists believe that liquid water periodically wells up through these cracks, refreezing and expanding. This process effectively resurfaces the moon, erasing older impact craters over geological time. And then something unexpected happened. Evidence suggests subduction-like processes on Europa. Sections of Europa's icy crust might be diving back into the warm ocean below, recycling material. This alien subduction would be driven by convection currents within the ice, rather than mantle rock. Such activity indicates a truly dynamic world, constantly reshaping itself from within. The resulting landforms are spectacular, from towering ice mountains to deep, winding canyons. Some canyons on Enceladus stretch for hundreds of kilometers, carved by massive ice quakes. These quakes release incredible energy as the moon flexes under Saturn's immense gravity. The continuous fracturing and refreezing also creates intricate networks of ridges and grooves. These features are like geological fingerprints, revealing the moon's internal struggles. They are testaments to a hidden power, silently sculpting these worlds over eons. These discoveries profoundly reshape our understanding of planetary habitability beyond Earth. The presence of liquid water, even beneath ice, drastically increases the potential for life. Cryovolcanism provides a mechanism to transport subsurface ocean material to the surface for study. Future missions could sample these plumes directly, searching for biosignatures without drilling deep. Moreover, the tidal heating driving these processes is a widespread energy source in the universe. Many exoplanets and exomoons might possess similar internal dynamics, fueling their own hidden oceans. This expands the habitable zone concept far beyond the traditional Goldilocks zone around stars. It suggests that life could thrive in places we once considered utterly inhospitable and dead. Expert perspectives emphasize the importance of understanding these unique geological engines. They represent fundamental planetary processes, just expressed through different materials and forces. The sheer scale of these geological forces is difficult to grasp, yet they operate continuously. Imagine mountains forming and oceans churning without direct sunlight, powered by pure gravity. These findings challenge us to think more broadly about the diverse forms geological activity can take. They remind us that our solar system still holds countless wonders awaiting deeper exploration. Every new image from these distant worlds reveals another layer of their complex geological story. These alien landscapes are not just beautiful, they are crucial laboratories for cosmic understanding. The icy moons of our outer solar system are truly geological marvels, silently active and profoundly complex. Their cryovolcanoes and ice tectonics reveal a universe far more dynamic and surprising than imagined. These untold stories of alien geology push the boundaries of what we consider possible for planetary life. They serve as a powerful reminder that the cosmos is full of unexpected beauty and scientific intrigue. Exploring these distant, frozen worlds continues to expand humanity's cosmic perspective. Their hidden oceans and dynamic surfaces promise even more astonishing discoveries in the future. If you found this deep dive into alien geology fascinating, subscribe for more incredible stories like this. Let me know in the comments which planetary landscape you find most mesmerizing. If you found this deep dive into alien geology fascinating, subscribe for more incredible stories like this. Let me know in the comments which planetary landscape you find most mesmerizing.